Good evening, everyone. Myself, Manish Kumar from NIT Agartala. I'm going to discuss the problem of code forces round 159 division 2. The problem code is sockets. Uh, I'm reading the problem statement. I'm simply reading. Vasa has got many devices that work on electricity. He has got N supply line filters to plug the devices. The ith supply line filter has AI sockets. Overall, Vasa has got M devices and K electrical sockets in his flat. He can plug the device's supply line filters directly. Of course, he can plug the supply line filters to any other supply line filter. The device is considered plugged to electricity if it is either plugged to one of K electrical sockets or it is plugged to some supply line filter that is in turn plugged to electricity. Now, what minimum number of supply line filters from the given set will washer need to plug all the devices he has to electricity? Note that all devices and supply line filters take one socket for plugging, and that he can use one socket to plug either one device or one supply line filter. The first line contains integer NMK, the number of supply line filters, and the number of devices, and the number of sockets that he can plug to electricity correspondingly. The second line contains n separated integers A1, A2, A3 up to AN. Number AI stands for the number of sockets. Yes, okay. I think you have all of you read the problem statement. I am simply understanding what the problem statement is saying. Here, N, M, K. N is supply line filters. Suppose here I want the first case. It is given 3, M is 5, K is 3. Here, what is N? N is basically a supply line filters. 3 supply line filters. I can say this is first supply line filters, this is second, and this is third. Okay. And M is total number of devices and K is extra sockets. K has sockets. Now the supply line filters also add sockets and yeah, and in the second line it is given that each supply line filters has some sockets. So there is, in the first test case, there is 3 supply line filters, and first supply line filters contain 3 sockets, 1, 2, and 3. Second supply line filters contain 1 sockets, and third supply line filters contain 2 sockets. Okay, now, and there are, what is K? K has, these are extra sockets. These are the extra sockets. I can name it, okay. I'm going to erase this. I'm going to erase this. Okay. Uh, Now, see, now, see, I'm going to taking first test case. Right, this is first supply line filters, second supply line, and third supply line filters. It has 3 sockets. It has 1 sockets. It has 2 sockets. Yeah. Okay. There are taking N, M, K, N is 3, M is 5, and K is 3. And these are the extra sockets. K1, I'm naming it K1, K2, and K3. Okay. Now, the question is saying that what minimum number of supply line filters from the Given set, first I need to plug all the devices. Now you have to find the minimum number of supply line. You have to find the minimum number of supply line filters to plug all the devices. Now it is five devices. See here, how many devices? It has five devices. Okay, it has five devices, and what I'm saying that suppose you are plugging. See, how can you plug the devices? You have five devices. Okay, now you have to connect. Suppose you are connecting the supply line filters to the first socket, then circuit is completed. You know what upper is written in that thing. No, I think you all have understood it properly. You have already read. Now I'm going to only plug the devices. Okay, now I'm going to connect the first supply line filters with that socket. Okay, now the first supply line filter has three sockets. Okay, now what we can do, I'm connecting first devices to this socket. I'm naming it D1, and second devices to these sockets, and third to these sockets. Now, how many devices we have left? We have left two devices. Okay, now we can directly connect to two devices with the available sockets. We cannot connect to the devices to this supply line filter there is no electricity because there is no electricity in that supply line filter. So what we can do, we can directly connect to the available sockets. Now all the five devices are completed. Now how many devices have you used? How many supply line filters have you used? You used only one supply line filter. Okay, so what we have seen, like in the first test case, we have in the first test case we have one is the output. Okay, now we are going to see second test case. And what second test case? Suppose n m k. It is given 4, 7, and 2. 4, 7, and 2. Okay, now it has four supply line filters. I'm going to say that first, second, third, fourth. First supply line filter has one, one, two, three sockets. Second supply line filters has three sockets. Third one has two sockets. Fourth one has four sockets. So basically, what we can do, and we have two sockets, extra sockets. I am naming it K1, K2. Okay. Now, first, first we have to check. First, you have to check. Now, what we can do? See here. Here, M is 7. M is 7. Okay. Now, you are connecting. If you connect, now I'm selecting that pipeliner we have, which has maximum sockets. So I'm connecting that first pipeliner, this sockets. So this circuit has completed. Now you can connect the devices in the pipeliners. Now, how many devices you can connect? You can connect maximum four devices in that socket. So, after completing four devices, after completing, suppose you are connecting four devices here. Suppose you have connected four devices. First, take an example. Now, what you can do? What you can do here is what you can do. What you can do after connecting four devices? Uh, how many devices you have left? You have left seven. You have left three devices. So what you can do? You can do that. What are the options here? Options here is that you can connect second. You have to connect second pipeliner to these sockets, or if you connect if we connect the devices to these sockets, so all the devices are left. All the devices will not be connected at any cost. So what we can do here, either you can connect second pipeline, so there is a use of second pipeline. Now extra sockets have used, you cannot use it further. Now what you can do, suppose now one second thing is that you have to choose second pipeliner which has maximum sockets. So I'm connecting this pipeliner to this socket. I'm not connecting this because I'm going to see which is maximum. Now, after connecting to these sockets, now we have three devices left. So you can directly connect to these three devices. And what are the other ways you can do? There is also other way of doing something. I'm going to explain this also way. So how many pipeliners you have used? You have used two pipeliners to complete all the devices. Now I'm going to explain another way. Okay. Now suppose now I'm taking another test case. Suppose I'm taking the first test case n m, okay, n is 3, m is 5, k is 3. Suppose I'm changing the values of m and k. Okay. Suppose I'm taking m is equal to 2 and m is equal to 2 and k is equal to sorry, m is equal to 3 and k is equal to 5. Now what you can say here that in the question it is already written that you can directly connect the devices into the sockets. What are those? Which sockets? Like this socket which is given extra sockets, not which is in the pipeliner, because whose circuit is not completed. Yeah, I think you have already understood. So we have sufficient number of sockets. We have five sockets, four, and we have less number of devices. So you can directly connect to the devices. How many maximum devices you can connect directly? Up to five. So if I'm writing the condition, if m is less than equal to k, so you have not used any pipeliner, so you may print directly answer 0 if m is less than equal to k. Okay, this is the first case. Now I'm taking a second test case. Now I've already explained you the second test case. Like in which case you have to print answer 1. Suppose, yes, like s- taking yeah, I've explained. I'm again explaining the first case like n m k. So here N is 3, M is 5, K is 3. Now here you can not directly put all the devices into the socket because M is greater than equal to K. So you have to first connect the first pipeliner. Now the first pipeliner has suppose 3 sockets. Now you have to choose first pipeliner which has maximum number of sockets. So I'm choosing the first pipeliner with sockets 3. Okay, so you have to use one sockets which you have to connect the first pipeliner with the given sockets. Now how many sockets we have left? We have left 2 sockets. Okay, and now um, and you can connect. So I've explained you already that you can suppose you are connected D1 and D2 here, D1 and D2. Now this is used, this is vacant. So see here, like we just 3 sockets, no? 3 sockets, no. So before vacating to this, you have to check whether whether after connecting all the devices using the first pipeliner and the available socket, is there is any devices left? If not left, then stop the answer till that. Then stop the answer till that. Okay. Then stop the answer. I am saying that like here, you may connect second pipeline to the this socket. So before connecting to second pipeline, you have to check whether all the devices are connected without using the second pipeline, whether all the devices will be connected or not. If not, then use second pipeline. Otherwise, print the answer as well as. Okay. Okay. Now I am explaining you the third test case. See here. Here N M K. Okay. Here what is 5 5 1. And each pipeliner has one socket. So I am taking the pipeliner which has maximum sockets. Okay. So we have to check whether NMK M is less than equal to or no. So you have to connect the pipeliners with the available sockets. So I'm connecting the first pipeliner which is I think 3 sockets. No? Okay. First pipeliner which is 3 sockets. I'm taking the pipeline which has maximum sockets. Okay. Now this has only one sockets. So I'm connecting to this in the sockets. So how many sockets you have left? You have left 0 sockets. Okay. Now you can, how many devices you have left? Suppose you have connected 2 devices. If you connect third devices, then you cannot connect all the devices. So you have not used. I think you are not. I think if you connect, if you connect all the devices, so you may don't connect another pipeliner. If you connect the third devices to this socket, you cannot connect further any devices and any pipeliners because you have no sockets. So this socket should be vacant. Okay. So what? So we have we have to connect this socket with the second pipeliner. Okay. So in the second pipeliner, how many devices you have? How many sockets you have? You have 2 sockets. So what we can do, you can connect third devices T1, T2, T3, T4. You have used no DT3. You have connected 3 devices. So if you have connected uh, T4, then uh, you may not connected any further devices and any further pipeliner. So you have to left this vacant and you may connect to the third pipeline. And how many sockets it is? It has one socket. So if you connect the devices directly, so you connect further devices and pipeline, so you have to connect it another pipeline. How many device sockets it is? This. So after connecting, yeah, now you have used first, second, third, fourth, and fifth, all the pipeliners, and in the fifth pipeliner you may connect T4. So after using all the pipeliners, one devices are left. So in that case, we have to print answer -1. I think you have understood the logic. Now you can code. Now you can code. Now you can code using the logic I have explained you. Okay. Now I am sharing the code with you. You can understand. You, mm, you can see and understand how I have used the code. Now I am opening my code. I am seeing you my code. Okay. Uh, um, See my code here. What I have done, I am taking the input nmk. I am taking an array n, count 0 y is equal to n. Even there, I am sorting. Why I have sorted? Because I am using that pipeliner which has maximum sockets. I have sort, and after sorting, it will be in an increasing order. So we uh, I have reversed to get first pipeliner which has maximum socket. So I am reverse that. So I am taking the first test case m less than equal to k. Then I am simply print the answer 0. In the second case, why what I have checked? I have checked. Uh, I have checked whether after using first pipeliner and the available sockets, either the socket is completed, either you have used all the devices and there is no devices left, then you may simply print answer 1. And in the other case, what you have done in the third case, okay, um, what I have done, okay, see here, see here, what I've done, I'm taking, I'm simply assigning here y is equal to n because there is a use of 1, so we have to update y. You cannot update n because there is a use of n, so I'm putting uh, n in the temporary variable y. So what you can do? So here I have used first pipeliner, so I'm updating my pipeliner as decreasing the value by 1. I'm taking m is equal to m minus a0. I have updated m, the devices I am connecting in first pipeliner. So here this case is the after greater than 1. So first we have to update m and k. So okay. Now I have run the for loop from I is equal to 1 to n. So in the if condition, I have checked whether using the second pipeliner, whether using second pipeliner is all the devices have used or not. So if I've used, then simply I have assigned m is equal to 0, and because it is completed, so I'm break. If break has been run, break statement has been run, then it will simply come out of the loop. So m is equal to, so it will print the value of count, otherwise it's print the value of -1. So thank you. So thank you. If you find this is helpful, please like, subscribe, and share my video. Thank you.